All right, today in math, we are going to be working on reviewing, adding, and subtracting fractions using another method called common denominator. If you have been using clocks or money and they've been working great for you, fantastic. I'm going to show you another way because not every fraction can be used with clocks and money, like sevenths, for example, are not going to work with either of those methods. So get your journal and record with me. So your first problem, 1/2 minus 2/5. Use whatever strategy is best for you. Pause and solve. Okay, so you might have used money here. So $1 is 50 cents. And yeah. And then if you flip back to when we were talking about money, 1/5 of a dollar is 20 cents. So 2/5 would be 40 cents. 50 cents minus 40 cents is 10 cents, which is 10 hundredths. Can't do fifths with a clock. So let me show you the common denominator way. So the first thing I'm going to look at is these bottom numbers, these denominators. They have to be the same to add or subtract the fractions. Right now they are not, so we can't do it. So I'm going to take a look at the 2, and I'm going to think, can I turn it into 5 using multiplication? No. Can I turn the 5 into a 2 using multiplication? No. I notice that this is a half. Can I half 5 easily? And I cannot do that either. So my easiest tool for common denominator would be to multiply them by each other. If I do it to the bottom, I need to do it to the top. So times 5 on the bottom, times 5 on the top. So now my denominators are tens. So 5 times 1 is 5. 2 times 2 is 4. And now I have a problem that I can solve because the denominators are the same. So again, remember, we don't add or subtract the denominator. They just come straight across. And now we have 5 minus 4 for 1. And if we look at these two answers, you might be thinking to yourself, Mrs. Ferber, those are different answers. How is it possible that they're the same? Remember, if you hide the 0 on the side, right, thinking back to our last unit with tenths and hundredths, these are equivalent fractions. So they all are the same thing. All right, let's try another one. 1/6 plus 1/2. Okay, so I'm going to start kind of pulling away from the clocks and from the money because we're going to start to get into fractions that can't use that quite as well. If you have that, if that's one of your most efficient tools, fantastic. Keep in mind that doesn't work for every fraction. So I'm going to show you how to do common denominator here. Okay, using multiplication, can you turn the 6 into a 2? No. But can you turn the 2 into a 6? And I can. 2 times 3 gives me 6. So I can bring the 1/6 down. And now my denominator is the same. So if I do it to the bottom, I need to do it to the top. 1 times 3 is 3. And now I have 1/6 plus 3/6. My 6s are the same, so I can bring that over. I have 1 plus 3 for 4. Little bit easier, a little bit more efficient than clocks and money. All right, let's try another one. 2 and 1/6 plus 3 and 1/10. Okay, with mixed numbers, you want to do the work with the fractions before you do anything with the whole numbers, especially with subtraction, because you might have to do some borrowing, which we haven't had to do yet, but just to be ready for that. So looking at the fractions, we have 1/6 and 1/10. Those denominators are different, so we're going to need to fix that. Can I turn the 6 into a 10 with multiplication? No. Can I turn the 10 into a 6? No. So The easiest thing for you might be to just multiply them by each other. So times 6, times 6, times 10, times 10. So then we're going to rewrite our problem down here. 1 times 10 is 10. 6 times 10 is 60. Plus 3. 10 times 6 is 60. 1 times 6 is 6. So now, same thing, we're still going to focus on these fractions first. So they both have 60. We can bring that across. And now we have 10 plus 6 for 16. Then I'm going to go back to my whole numbers. 2 plus 3 for 5. I'm going to show you an example of why this is important. So let's pretend this was subtraction. I'm going to rewrite the problem a little differently here. 3 and 6 60ths minus 2 and 10 60ths. So, showing you an example here, right? So the 60s are still the same, but now you have 6 and they want 10. This is why it's really important to do the fraction first, because now I have to borrow, which means I gotta turn this 3 into a 2. And remember that each whole is 60 pieces. So I have to add 60, which really gives us 2 66 60ths minus 2 and 10. Right? This makes it a little bit different. This is why we always do the fraction piece first, because had you needed to borrow and had already done the 3 minus 2 for 1, you would end up getting the wrong answer because we had to break one of them apart. So now we have 66 minus 10 for 56, 2 minus 2 for 0. So very different answer when you need to borrow, which is why we always do the fraction part first. All right, let's do another one. We'll do 1 and 2/10 minus 3/10. Go ahead and pause and solve. Let's see how you did since I just modeled something similar up above. Okay, so hopefully first thing you did was check those denominators. They're both tenths. Fantastic. Bring that across. But now you have 2 and they want 3. If you have 2, they cannot take 3 away. So you had to borrow, which takes this one whole. And there are 10 pieces in this whole, so you're going to add 10, which turns your fraction into 12/10 minus 3/10. So 12 minus 3 would give you 9/10. How'd you do? Guess what? If you made a mistake, it's okay. You have a pencil. You can fix it. It's called learning. Fantastic stuff. All right. We'll do 2 more here, and then we'll jump over to the workbook page that we're going to do today. So 2/3 minus 1/4. So first thing you're going to do is check those denominators. Are they the same? No, they are not. Pause and see if you can give me a common denominator, a number that is the same. Let's see how you did. So, can I turn a 3 into a 4? No. Can I turn a 4 into a 3? No. But if I multiply them by each other, do it to the bottom, do it to the top, do it to the bottom, do it to the top. Now, I have 12ths. 4 times 2 is 8. 1 times 3 is 3. Now I have 8 minus 3, which is 5. All right, let's try one more in here and then we'll jump over to our workbook. 1/5 plus 7/10. Pause and solve. All right, so checking those denominators, they are not the same, so we cannot do anything yet. We have to fix it. Can you turn a 5 into a 10 with multiplication? Yes, you can. Times by 2. So if I do it to the bottom, I need to do it to the top. So now I have tenths plus 7/10 equals some number of tenths. So 2 times 1 is 2. So 2 plus 7, 4, 9 tenths. Good work. Okay, so set that off to the side, and hopefully you have your workbook, and I would like you to open to page 49. We're going to do some work in here today. So pause if you need to. Working on page 49. So today we're going to work for the second half in our workbook on fraction estimate and check. So when it says estimate in a problem, that does not mean give the exact answer. That means give an about answer. So we're going to do a little bit of that here. We're going to put our estimation in this first problem. Then we're going to work it out and get an actual answer. So let me walk you through their example problem here. So they have 8/3 plus 9/12. 8/3. So this is called an improper fraction, right? Because that top number is bigger than the bottom number. Zoom in a little bit here. This is almost 3. If I were to round, right? This is almost 3. Oops, I wrote 9. This is almost 3. This is almost 1. So if I add them together, the answer is going to be a little bit lower than 4, right? So they said their answer is going to be more than 3. So I'd say the answer is about 3 to 4. So then when you go through and you solve your work, if you end up with an answer that's like 15, you know you've done something wrong because you said your answer should be about this much. That's the point of estimating, to help make sure you're on the right track and that something didn't go goofy with your math. So let's work through number 2. So we have a half and about a half. So the answer, right, sum meaning the answer to an addition problem, the difference for this one is going to be about. Notice that when you're doing estimations, your equal sign is wavy because we're talking about a certain number. So whenever you're talking about, I don't know about you, but with me, my hand kind of shakes. I'm like, oh, it's about 4 years old. It's about a pound. So that's what helps me remember to make my lines wavy, is about. So this answer is going to be about 0. So my answer should be really small when I go to solve it. So we have a half and we have a 12th. Those are not the same denominator. So I don't want to solve it. I got to fix it. Can I turn the 2 into a 12 using multiplication? I can. So if I times the bottom by 6 and times the top by 6, now I have 6/12 minus 5/12. So what's our answer here? We know it's going to have a 12th on the bottom. 6 minus 5 leaves 1. So 1/12, that's pretty small. It's pretty close to 0, so I know that my answer is right. All right, I'm going to help you estimate this one, but we're going to try you solving it on your own. So this one is less than a half. This one's almost a whole. So I would say, right, so this one's about a half. This one's about a whole. I'm going to say our answer should be about 1.5. Pause and solve. See if you can figure out where we actually land. All right, check those denominators. A 10th, a 5th. We can't do it. Can I turn a 10 into a 5? No, but I can turn a 5 into a 10. So if I times this by 2, I do the same thing to the top. Now I have 3/10 plus 4 times 2 is 8/10, which gives me some tenths. So 3 plus 8, 8, 9, 10, 11. All right, so this is an improper fraction. So I'm going to ask myself, how many groups of 10 can I take out of 11? And I can take 1 out, and that leaves 1 behind. So our answer is not super close, but we're also only off by 4/10. So I would say we're right. All right. Why don't you try estimating this one and see where you land? Okay, so this one We'll call it about 1. We'll call this... Oh, that's pretty small. This is... So I think our answer is going to end up being somewhere around a half. This one isn't quite 0. This one isn't quite 1, but they are going to take some bits and pieces away. So I think our answer is going to land somewhere around a half. Pause and solve. See how you do. Whoops. Okay, so looking at these denominators, they are not the same, so we need to do some fixing. So, can I turn a 4 into a 5? No. Can I turn a 5 into a 4? No. But I can multiply them by each other. So I'm going to times this by 4, and I need to do it to the top. I'm going to times this by 5, and do it to the top. 4 times 5 gives us 20, minus some more 20ths, so 5 times 3 is 15, and 1 times 4 is 4. So we're going to end up over here in 20ths, so 15 minus 4 gives us 11, which is pretty close to a half. Good work. All right. I need to move my board a little bit here. Hiya! Come on, camera. There we go. Okay. Try to estimate this one. Holy moly, look at there. Improper fraction. That number on top is bigger than the bottom. This is actually 2. This is subtracting almost 1. So I'm going to say our answer is going to be close to 1. Try actually solving it. Let's see what happens. All right. Can I turn the 6 into a 12? Yes, I can. Times that by 2. If I do it to the bottom, I need to do it to the top. So now I have some 12ths minus 8 12ths gives us some number of 12ths. Okay, so 2 times 12 is 24. 24 minus 8. So 24 minus 8. If I take 4 away, it gives me 20. 19, 18, 17, 16. I can even check it and go backwards. 16, 17, 18, 19, 20, 21, 22, 23, 24. Ooh, I'm right. So we get an answer of an improper fraction. How many groups of 12 can I take out of 16? I can take out just 1. So 16 minus 12 leaves me with 4 of those pieces left behind. Both of those are considered correct answers. So if this turning it into a mixed number part is a little confusing for you, give it a try, but both of those are technically correct answers. All right, last one. Estimate. Let's see how you did. So 8 12ths. Oop, that's bigger than 1. I'm going to call that like 1.5 plus almost 1. So I'm going to call our answer almost 1, almost 1.5. I'm going to call it 2. Pause and solve. Let's see how you did. Okay. Can I turn the 8 into a 4? No, but I can turn the 4 into an 8 if I times it by 2, which means I need to do it to the top. So 12 8ths plus some more 8ths is going to equal some 8ths. So 3 times 2 is 6. 12 plus 6 is 18. 18. Well, I know if I double it, it gives me 16. So 2 and 16, 17, 18. 2 and 2 8ths. Not far off. Good work today. Make sure to come check in with your teachers if you need any help on today's independent practice. And I'll see you tomorrow with some more. Bye, guys.